So this is assignment related to intermolecular forces. In this session, we will discuss question 21 onward. In the last session, we already completed the first 20 questions from this sheet. So question 21 and onward we'll solve today. First, for question 21, the OH bond in water is polar because compared to that of hydrogen atom. The oxygen atom has so why the bonds are polar, the bond polarity depending on the electronegativity, and the definition of electronegativity, tendency to attract the shared pair of electron, that's called electronegativity. So if the atom is having a high electronegativity or element is having a higher electronegativity, then the bond will be, the polarity of the bond will increase. So the shared pair of electron is there between oxygen and hydrogen. As oxygen is more electronegative, so this shared pair is shifted more towards oxygen. So oxygen will get partial negative and hydrogen will get partial positive. So the OH bond in water is polar. Compared with hydrogen atom, oxygen has greater electronegativity, greater tendency to attract electron. So C will be the right answer. In question 22, which of the following compounds has the highest boiling temperature? So when we work out the boiling temperature, we have to check the type of forces present, like CH4 methane, as it's a non-polar molecule. So non-polar molecule, it will have dipole-induced dipole forces or London dispersion forces. CH3Cl, so the molecule bond will be polar as well as molecule will be polar as well. So it will have dipole forces. Aldehyde HCHO. So because the bond is there between carbon and oxygen, and that bond will be polar, and whenever the bond is polar, that will have dipole force. When we compare CH3OH, so there is oxygen bonded with hydrogen. When hydrogen bonded with oxygen, nitrogen or chlorine, and they have the lone pair, then it can form a hydrogen bond. So this will have hydrogen bonds. And hydrogen bonds are stronger compared to dipole forces, and dipole forces are stronger as compared to dipole-induced dipole forces with the same number of electrons. So D will be the right answer because it can form a hydrogen bond. The strongest intermolecular force in liquid ammonia are intermolecular force. So covalent bond is not an intermolecular force, it is intramolecular, because that is, in case of ammonia, it is a simple molecule. So this is a covalent bond, and this is intramolecular force, the force within the molecule. So that cannot be. It's when nitrogen bonded with hydrogen and there's a lone pair, so it can form a hydrogen bond. Then dispersion forces will be there, or London forces will be there, but that is weaker. And permanent dipole, yes, there will be permanent dipole as partial negative and positive, but it will be not stronger. The strongest one will be the hydrogen bond. So B will be the right answer for question 23. Is it clear? Question 21, 22 and 23. So we can move on to the next question. Is it clear, this one? In question 24, the graph below shows the boiling temperature of group 5 hydrides. So what will be the likely position for ammonia NH3? So in case of NH3, because ammonia is basically a gas And if it can form a hydrogen bond, why it can form hydrogen bond? Because nitrogen can uh, hydrogen bonded with nitrogen, and nitrogen having a lone pair, so that it can form a hydrogen bond. So it should have a higher boiling point compared to that of pH3, which will have permanent dipoles as well as London dispersion forces or weak van der Waals forces. And these weak van der Waals forces get stronger as the number of electron increases. That's why for arsenic hydride as well as the other hydrides for group 5, the boiling point is increasing. So position of NH3, that is defined by A. Because it can be B, but B you can clearly see very small differences there, but this is having a hydrogen bond. So hydrogen bond is stronger, that's why it will have a greater difference with phosphorus hydride. In question 25, which of the following compound has the highest boiling temperature? The relative molecular masses are given. So how you can work out the highest boiling temperature? You have to check the type of intermolecular forces. So cyclopentane, it will have dipole-induced dipole force or London dispersion forces. For pentane, it will also have dipole-induced dipole or the London forces. Butane, one all, because the OH group is there. I'm talking about the major forces. It will have dipole-induced dipole force as well, but the major force is a hydrogen bond. And ethane 1,2-diol, the major will be hydrogen. Now, as we know, hydrogen bonds are stronger, but which one is forming more hydrogen bonds? As you can see, it is ethane 1,2-diol. So di means two OH groups are there. Whereas butane 1-all, it is having only one OH group, so which will have the stronger hydrogen bond. So ethane 1,2-diol will have stronger hydrogen bond. That's why D will be the right answer. Which of these molecule is polar? So how to identify a molecule may have a polar bond but may have a non-polar structure if it is symmetrical. So when we draw the structure for each, like we draw carbon dioxide, CO2, so it is a linear structure. The bonds are polar but overall molecule, because there is a symmetrical, so the overall molecule is non-polar because there is a symmetry. Say when we draw NH3, one bond pair, three bond pair and one lone pair, and this is partial negative and positive. So what we will find, we don't find a symmetry in the structure. So bond polar as well as the molecule will be polar as well. So this will be polar molecule. Carbon tetrachloride tetrahedral structure, bond will be polar but overall molecule is having a symmetry, so it will be non-polar molecule. And same thing for CH4, the bonds are non-polar because a small difference in the electronegativity between carbon and hydrogen, as well as the molecule is non-polar. So this is non-polar, this is also non-polar. But in case of NH3, because there is no symmetry here, as one of the bond is shorter, as one of the bond of carbon, nitrogen and hydrogen is shifted, so it does not have a symmetry from both sides. That's why the overall molecule will be a polar molecule. Is it clear? Question 25 and 26. So if there is a symmetry in the structure, then maybe the bonds might be polar, but overall molecule will be non-polar. If it's not a symmetrical structure, then the molecule will be a non-polar molecule. Moving on to the next question. In question 27, which of the following compound has hydrogen bonding in a liquid state? So HBr, hydrogen bromide, it will have, because bromine and hydrogen does not have the same electronegativity, so it will have dipole forces as well as dipole induced dipole. Hydrogen sulfide as well as silane will have dipole induced dipole, but because hydrogen bonding exists when nitrogen bonded with hydrogen, when fluorine bonded with hydrogen, and when oxygen bonded with hydrogen, as they are the most electronegative elements with the lone pairs on them. So D will be the right answer for this question. Next question, in a molecule of hydrogen, two hydrogen atoms are held together. So in a molecule of hydrogen, two hydrogens are held together by two hydrogen atom. So between the atom, what they have the shared electron, and they don't have difference in the electronegativity. So they will form a non-polar, because hydrogen bond is not an intramolecular, it is intermolecular, so that cannot be a polar covalent bond. If two atoms have difference in electronegativity, then it will be polar. A non-polar, so because the two atoms does not have any difference in the electronegativity, so it will be a non-polar. And London forces, that exists when but that is also intermolecular force, not a intramolecular. But in this question, they're asking for intramolecular force between the molecule, within the molecule, or between the atoms. Yeah, non-polar covalent are 100%. Yeah, that's true. In question 29, at room temperature, iodine is solid and bromine is liquid. The best explanation. So it means that iodine is having a strong intermolecular force as compared to that of bromine. Iodine, and both are non-polar molecules, and non-polar molecules, they have dipole induced dipole forces, and that increases as the number of electron increase. So iodine, bromine has a weaker permanent, they don't have weak permanent dipole, that's wrong. Bromine is more volatile. The term volatility means it can easily vaporize, but that does not explain the statement. It is volatile, that's true. It can easily be converted into vapor, but that does not explain the statement. Iodine has a strong covalent bond. Both have, iodine is larger in size, so the melting and the boiling temperature does not depend on the covalent bond. It depends on intermolecular force, which are dipole-dipole or dipole-induced or hydrogen bond. So because the iodine is having a strong London forces, that's why it is solid at room temperature as compared to that of bromine, which is liquid. In question 30, consider the following compounds P, Q, R, and S. The boiling temperature of a compound increasing order. So first thing, we check the number of the carbon atoms, and then we check the type of intermolecular forces between them. So compound P is a straight chain. This is a branch. So straight chain will have high boiling point, and the branch one will have low boiling point. Then this is straight chain and this is branch. So straight chain will have a high boiling point and branch will have a low boiling point. But when we compare the type of the forces, This because this will have dipole, induced dipole or London forces as a straight chain and a carbon is there. This will also have London forces. This will have dipole forces which are stronger. This will also have dipole. Other will be there, but I'm talking about the major force, dipole force. So first, when we compare, because the dipole forces are stronger, then London forces are weaker force. So first, it should be Q. Q should have the lowest, then followed by straight chain will have a higher, but it cannot have higher compared to dipole. So it will be P. Then when we compare the branched compound with straight chain, so branch will have low boiling point, so it will be S. And then the last one will be R. So it matches with option A. So you have to check whether it's straight or branch, and then you have to check the type of intermolecular force exists. In question 31, methanol dissolve in water mainly due to formation of, so methanol, when we draw the structure of methanol, meth means one carbon and all means OH group is there. So because oxygen is there and bonded with hydrogen, and inside water there is oxygen for, so what they can do, they can form a hydrogen bond with each other. That's why it can easily dissolve. So for question 31, A will be the right answer. In question 32, hydrogen iodide has a higher boiling temperature than hydrogen bromide. This is because, so you have hydrogen iodide, they mentioned it is having a higher boiling point compared to hydrogen bromide. So they have dipole force and they have dipole induced dipole forces, and dipole induced dipole forces increases as the number of electron increase. So when we compare the option, hydrogen iodide is stronger, the bond, it's not about the intramolecular, so that's strong. Hydrogen iodide has a stronger London forces, that's true, because it is having more electron, so it will have a higher greater or stronger London force. Hydrogen iodide has a large, it does not have large permanent dipole. Hydrogen bromide is having permanent dipole, and hydrogen iodide forms hydrogen bond, but both of them are not able to form any hydrogen bond. So B will be the right answer for this. Yes, all molecules have London forces and it increases as the number of electron increase. So when we say, even like example, you are having methanol, so methanol will have London force, but it will be weaker. The main cause of dissolving or having a boiling point higher, that is related to hydrogen bond. So all the molecules have London forces, and that increases, the effect of the London forces increases as the number of electrons increase. In question 33, butane having a higher boiling temperature than 2-methyl propane. This is because, so butane, it's a straight chain, whereas 2-methyl propane is a branch, so this will have large surface area, that's why it will have higher boiling point. Because right now they have the same number of electrons. So if they have the same number of electrons, so London dispersion force will be same. Now it depends on how many parts they're interacting. because it's a straight chain, so it will have a large surface area, greater parts it can interact. In question 34, sodium chloride is more soluble. Sodium chloride is more soluble in water than in hexane. This is because, so what is the reason why sodium chloride is more soluble? Uh, intermo in, the intermolecular forces between water molecule are stronger than, that is not the reason about the solubility. Hexane molecule cannot fit, that's also not the reason. But what happened? The hydration energy is released when the water molecules surround the sodium ion and chloride ion, and that energy causes the crystals or the particles, the lattice to the ions in the lattice to separate from each other. So C is the right answer. And sodium ion and chloride ion forms hydrogen bond. They are not forming hydrogen bond. That is called ion dipole force or bond. So C is the right answer, that energy is released when ions in sodium chloride are hydrated, because hydration energy is always exothermic. But why, uh, like not all of the salts are soluble? Because their hydration energy is less than the lattice energy. So the lattice is not able to break from the hydration energy. In question 35, both ethanol and propane have a molecular mass, so they have the same molecular mass. Suggest which substance will have the higher boiling point and justify your answer by comparing. So ethanol, if you draw the structure, this will be ethanol, C double bonded with ONH, aldehyde, and we have propane, so CH3, CH2, CH3. So this will have partial negative and positive. So dipole, there, or the type of forces, it will have dipole induced and, or you can also say London forces and permanent dipole. Whereas this will have London forces. So only one type of force is there, the intermolecular. So this will have higher boiling point. So ethanol boiling point will be higher, and then you will mention your, in your answer you will mention that reason is that it's having permanent dipole or dipole forces, where in propane it's having only London forces or Van der Waals force, or you can also say dipole induced dipole forces. In question 36, the boiling temperature of some hydrides are given below. So HF is there, HCl is there, HBr, HI, and H2O. Explain by comparing the forces involved why HI higher boiling temperature than HBr. So the forces which they have the major forces, they have permanent dipoles, but the major forces, the London dispersion force for HI is greater than, so London dispersion forces are stronger compared to HBr, and the reason is that because having more electrons, or you can mention electron shells as well. Next part explained by comparing the type of forces involved in HF, why HF is having a higher boiling temperature than HCl. So HF is having hydrogen bond. So when we compare the intermolecular forces in HF is having a hydrogen bond, where in HCl it will have permanent dipole or dipole-dipole. And dipole-dipole hydrogen bonds are stronger. The point which we will include, so fluorine is more electronegative than chlorine. So you can compare even the dipole-dipole forces as well. And hydrogen bonds are stronger. So greater energy is required to overcome the intermolecular forces and change the state. Then part C suggests why H2O is having a higher boiling temperature than HF. As you can see here, H2O is 373 Kelvin, but HF is 293 Kelvin. So even though the hydrogen bonds of HF are stronger, but still HF is having a lower boiling temperature as compared to H2O. So the main reason is about the number of the bonds. So water form up to 2 hydrogen bond per molecule, but in HF it only forms. So when you draw the structure with one molecule, there is one, as you can see, like example, if I draw the structure of HF, even though fluorine is having three bond pair, one bond pair and three lone pair, and there is another molecule. So this is partial negative, partial positive, partial negative, partial negative, partial positive. So there is an attraction, and the bond angle is always 180, the hydrogen bond. So it is able to form only one. But what happen in case for water, H2O, which is having two bond pair and two lone pair, so this can form a hydrogen bond as more hydrogens are available. Why in this case, like why the molecule cannot form a bond, hydrogen bond with these lone pairs, as these electrons are repelling each other, so the molecule cannot fit in this space. But in case of water, more hydrogens are available. As greater number of hydrogens are available, it can form more hydrogen bonds per molecule. So greater possibilities are there, more hydrogen bonds per molecule. That's why for hydrogen fluoride, even though lone pairs are available, but hydrogens are not available. So more hydrogen bonds per molecule, which leads to higher boiling point for H2. Is it clear, this concept? Question 37. Draw a dot and cross diagram for carbon dioxide. So dot and cross diagram for carbon dioxide. Carbon belongs to group 4, so it will share 4 electrons, and oxygen belongs to group 6, so it will share 2 electrons, and there will be 2 lone pair. This is a dot and cross diagram for carbon dioxide. London forces between molecule of carbon dioxide are stronger than London forces in methane. So suggest a reason for that. So when we compare, it's about the like in methane, carbon is having 6 electrons and hydrogen is having 1 electron, but there are 4, so it should be multiplied by 4, so total will be 10 electron. But in carbon dioxide, carbon is having 6 electron and oxygen is having 8 electron multiplied by 2, so 16 plus 6, that is equals to 22 electron. So carbon dioxide 22 electrons, wherein methane it is only 10 electrons. That's why methane is having a low boiling point and carbon dioxide is having a high boiling point. So you will mention, because more electrons in CO2 result in higher boiling point. Use your knowledge of intermolecular force. Suggest why butane has higher melting temperature than 2-methyl propane. So this is when they have the same number of electrons, you will compare which one is branch and straight. So butane is having a greater surface area, it is having less branches, so more contact between the neighboring molecules. So butane is having less large surface area, so more contact with the neighbor molecule. That leads to higher boiling temperature. When carbon dioxide is dissolved, it may eventually form a mineral such as magnesium carbonate and calcium. So state the result for flame test. Flame test for magnesium. For magnesium, it is giving energy, but that is not in a visible range, so there is no characteristic flame color. It is giving energy, but that is not in a visible region, so we don't see any change in the flame color. But for calcium, it is giving a brick red. Question 38. When when chlorine is passed over iodine, it forms ICl, iodine monochloride, is in liquid at room temperature where chlorine is gas. So we have to compare the intermolecular forces between them. That why chlorine is a gas, whereas ICl is a liquid at room temperature. So in case of ICl, it will have major forces. It will have dipole induced dipole, but the major force will be permanent dipole, as chlorine more electronegative than iodine. Then Cl2 will have London forces, and dipole or permanent dipole forces are stronger. In ICl are stronger compared to Cl2 dipole London forces or dipole induced dipole forces. So it required greater amount of energy is needed to overcome. That's why it is having Yeah, Cl2 is a non-polar molecule, so it will have dipole. You will mention the reason as well, like Cl2 is a non-polar molecule, so it has London forces, and then even you can compare the London forces as well. They will have dipole. Yeah, only London forces for Cl2 and permanent dipole, as well as London forces for ICl. And even London forces in ICl will be stronger because there are more electrons. So ICl is having a permanent dipole as Cl is more electron, and London forces, and London forces are stronger in ICl as well, because more electrons are there. So this will be the answer for this question, which will you get 4 marks. Then another question is hex 3-ene-1-ol is sparingly soluble, slightly soluble in water, but completely miscible in ethanol. By reference to intermolecular force, why the difference in solubility? So double bond is there, OH is there, and carbon chain is also there. Where so it is sparingly soluble in water slightly, but it is completely miscible with ethanol. So when we compare the forces, so in Z hex 3 in 1-ol, it has London forces as well as hydrogen bond. And because of long chain, so due to long chain, it is mostly non-polar, so major forces are London forces. Because the concept is light dissolved light, so major forces are London dispersion forces. So why it is sparingly soluble? Because so it is sparingly soluble because of London forces and completely miscible in water due to London forces and completely miscible with ethanol because both forces are present in ethanol as well. Is it clear? So basically, you should mention that it is having two type of intermolecular forces, London forces as well as hydrogen bond, and mostly it's a non-polar, so mostly it will have London forces, and it can form both hydrogen bond and London forces between ethanol. That's why it is completely soluble. But with water, it can only form hydrogen bond, but there is no London forces, so it is slightly miscible. Water, the strongest one is the hydrogen bond. It should have both type of forces should be there. So question 40. The graph identify the type of intermolecular force give rise to unusually high temperature for hydrogen fluoride. So that is hydrogen bond. I'm writing in short HB. Then state and explain whether the electronegativity of fluorine is greater than or similar or less than bromine, and explain why hydrogen fluoride. So it is electronegativity. Fluorine is more electronegative. So fluorine is more electronegative and it will form hydrogen bond. Yeah, that's right. And fluorine is smaller, so less shielding effect. That's true. So next session we will continue this. Any question related to the class today? So I'll end the session and share this accordingly.